Hello and welcome back. Today we are talking about the empirical rule. If you did not already watch my video on normal distribution, I highly recommend checking that out first. I introduced the empirical rule in that video. Here we're just going to dig a little further into it. All right, let's begin. So the empirical rule, also called the 68, 95, 99.7 rule, describes how data are distributed in an approximately normal distribution. It provides quick estimates of the percentage of observations within 1, 2, and 3 standard deviations of the mean. The empirical rule should only be used when the distribution is approximately normal, bell-shaped and symmetric. That's the distribution type we see with a normal distribution. It does not apply to skewed or unusually shaped distributions. All right, so here we have the rule. About 68% of observations lie within plus or minus 1 standard deviation of the mean. About 95% of observations lie within plus or minus 2 standard deviation of the mean. And about 99.7% of observations lie within plus or minus 3 standard deviations of the mean. All right, so what does that look like? Here we have a graph breaking that down. Cool, we can see it. All right, so here we have mu, our mean. And I really like this graph because it breaks each section in half. So we can see here, this is our mu, or our mean plus 1 standard deviation, and this is our mean minus 1 standard deviation. So right here in the blue is our plus or minus 1 standard deviation. So right here we have the total percentage. This total area is 68% of the data, but we could break it down a little further and say, okay, well, just minus 1 standard deviation is 34%, and plus 1 standard deviation is also 34% of the data. The next part, plus or minus 2 standard deviation, we have in green here. Now, again, it continues to break it up. What it says here is between minus 1 and minus 2 standard deviation, we have 13.5% of the data. Likewise, from plus 1 standard deviation to plus 2 standard deviation, we have 13.5% of the data. But if we look at everything, let's do it in the marker. If we look at everything, maybe try the highlighter. There we go. If we look at everything here, let's make that a little bit. Okay. So now this is saying everything from minus 2 standard deviation all the way to plus 2 standard deviation accounts for 99.5% of the data. Okay. But just this part here between minus 1 and minus 2 is 13.5, and plus 1 plus 2 is also 13.5. Okay. And lastly, we have the mean minus 3 standard deviation to the mean plus 3 standard deviation. Likewise with this area, between plus 2 standard deviation and plus 3 standard deviation accounts for 2.35% of the data. Likewise, from minus 2 standard deviations to minus 3 standard deviations is another 2.35% of the data. But if we look at everything, that orange doesn't show too well. Let's just draw it in. If we look at everything here, there we go. That's more visible. Okay, now this is saying everything from the mean minus 3 standard deviation all the way to the mean plus 3 standard deviation accounts for 99.7% of the data. Okay. And then just at the end, to the left of the mean minus 3 standard deviation, we have 0.15% of the data. Likewise, the mean plus 3 standard deviation, 0.15% of the data. That accounts for the little extra we're missing here to give us a full 100%. And as discussed in the normal distribution video, the curve continues infinitely without ever approaching the x-axis. It just continues to get infinitely close without touching. The idea of infinitesimals is discussed further in calculus. We're not going to go there. But when you take a calculus-based approach to statistics and more importantly the normal distribution, you get some pretty interesting stuff. But again, that's way ahead of myself. All right. And then here I just kind of have written out everything I discussed. 34% of the data lies between the mean and +1 standard deviation. 34% of the data lies between the mean and -1 standard deviation. And this accounts for our 68% right here. 13.5% of data lies between +1 and +2 standard deviations. Another 13.5% lies between -1 and -2 standard deviations. And if we add all this up, that accounts for 95% of the data. Continuing forward, 2.35% of the data lies between +2 and +3 standard deviations. 2.35% of the data lies between -2 and -3 standard deviations. All of this added up accounts for 99.7% of the data. And lastly, roughly 0.15% of the data lies beyond +3 standard deviations, and roughly 0.15% of the data lies beyond -3 standard deviations. And if we add all this up, we get 100% of the data. Typically, we don't worry about the beyond range, but I just wanted to include it so we can have that nice clean 100%. Okay. So here we have an example. Test scores are approximately normal with a mean of 75 and a standard deviation of 8. Okay. So what would that look like? So where our mean is, you could see we put 75 here. And then because our standard deviation is 8 at each, we'll call it interval, we just increase by 8. So +1 standard deviation is 75 + 8 is 83. At 2 standard deviations is now 83 + 8 is 91. And at 3 standard deviations is 91 + 8, 99. And then going in the negative direction, 75 at -1 standard deviation, we do 75 - 8 to get 67. At -2 standard deviations, we do 67 - 8 to get 59. And then at -3 standard deviations, we do 59 - 8 to get 51. Okay. And that tells us approximately 68% of scores are between 67 and 83. Approximately 95% of scores are between 59 and 91. And approximately 99.7% of scores are between 51 and 99. Some common mistakes. Applying the empirical rule to a non-normal distribution. It's probably going to be in my next video. I'm going to discuss what we would use for a non-normal distribution. I believe it's called Chebyshev's theorem, some Russian name. I'll get it right in that video. Forgetting the percentages, 68, 95, 99.7. You say them enough times, you will remember them. This is like seared into my brain at this point. Using the wrong multiple of standard deviations, we always use +-1, +-2, +-3. That's it. Okay, only numbers we should see. And then assuming that the mean is not the center of the distribution, we must remember the mean is always put at the center. Okay. All right. Let's take a look at a practice problem. Height are approximately normal with a mean of 70 inches and a standard deviation of 3 inches. Find the intervals that contain approximately 68%, 95%, and 99.7% of heights. Take a minute to pause it here and take a stab at this problem. All right. Hopefully we paused and tried to work on it on our own. Let's take a look at the solutions. So here we're given, I just rewrote what we're given. I always do this. The mean is 70 and our standard deviation is 3. Okay. Mean 70, standard deviation 3. So we just continue to add or subtract 3 from this number to find our intervals. So the first one is the mean plus our standard deviation of 3 gives us 73. And then the mean minus our standard deviation, 70 - 3, gives us 67. Continuing forward, the mean plus 2 standard deviations. Now you could do, technically you're allowed to do this. You could do, the mean is 70 plus 2 times 3 equals 70 plus 6 equals 76. That's one way to get the 76 there. Since it's 2 times that number, I simply just add 3 from this one. I just find that a little bit easier. It's how I usually do it. Likewise, for -2 standard deviations, we subtract 3 from this one, get our 64 there. And we're just going to continue forward with the same pattern to find 3 standard deviations. We add 3 from our we add our standard deviation of 3 to our +2 standard deviations. 76 plus 3 is 79. And then in negative direction, 64 - 3 is 61. So then we could say 68% of the data is 67 to 73 inches. 95% of the data is 64 to 76 inches, and 99.7% of the data is 61 to 79 inches. And here I drew out what that would look like. It might be a little bit messy. I just copied the previous normal distribution and just input our values for it. So the mean is 70, okay, plus 3. 73 is our mean plus 1 standard deviation, plus 3. 76 is our mean plus 2 standard deviation, plus 3. 79 is our mean plus 3 standard deviation. And then going to the negative, again, we start with 70, minus 3. 67 is our mean minus 1 standard deviation, minus 3. 64 is our mean minus 2 standard deviation, and then minus 3. 61 is our mean minus 3 standard deviation. And then we could see here the range of all the test scores. Okay, cool. And that's everything I have for you on the empirical rule. Almost forgot the name of it. Anyway, that's everything I have for you on the empirical rule. Thank you for tuning in. As always, a link to the notes will be in the video description, and I will see you next time. Take care.